All right, thanks everyone for coming. Let's go ahead and get started a minute early so we can squeeze in as much AI as we can. My name is Chris Lauren. I'm a program manager in our AI platform team. I'm here to talk to you about Visual Studio tools for AI and Visual Studio Code tools for AI. They're free extensions that you can download, install in your IDE or editor of choice that enables both training custom AI models and also infusing your applications with AI, either pre-built cognitive services that are available in the cloud, or a model that perhaps a data scientist down the hall trained, or that you found out on GitHub. I'm going to show you how to take those models, generate some code, include that code in your application, and run it, and hopefully have a little bit of fun. So the big question that probably most people have is, I've got this idea, I think AI might apply. I want to figure out how to actually take this idea and build it and create some profit, right? How do we do this? So the easiest way is just use the pre-built AI, like cognitive services or a model that you might find in a model gallery, a model zoo. People call these things a lot of different things. But with AI, one of the super interesting things that I love about working in the space is that people are willing to share their code, they're willing to share their data sets, they're willing to share their pre-trained models, and you can usually download the examples and get started pretty easily. So rather than just reading a bunch of textbooks in kind of the abstract sense, you can download sample projects and get started really easily. So how do we do that? Well, one way we can use this pre-built AI is the cognitive services. You can just think of these as basically models that we've trained in the cloud, where a model is kind of like a skill, if you will. The ability to take an input image and identify the face and give you some characteristics about the person in the image, or describe the scene, or give you some semantic analysis of some text input, for example. That is a model, and that model just happens to be running in the cloud. Now, sometimes there's multiple models that work together, and I'll show you how this works to include some really cool capabilities in your application. So there's a bunch of these cognitive services that are pre-built. You've probably seen some of the other sessions talking about them. If you haven't checked it out yet, please go ahead and go to the website. They have cool capabilities with respect to vision scenarios, text scenarios, speech scenarios, and more, that if you're, as a developer, simply generating some code, calling those services in the cloud has never been easier. So I want to show you how to do that. Now, in the slide deck, I've captured some slides just so that when you download the slide deck later, then the demos don't get lost in translation. But rather than just showing slides all day, and this is Visual Studio, so I want to show you some actual code here, right? So in Visual Studio, we've added some new project templates. So you can say File, New Project, and select Cognitive Services, for example. You can see we've got vision, we've got search, we've got text, a bunch of different things. So you can select one of these templates, click Next, and it's going to generate some code wrappers for you to actually call these cognitive services. However, you might say, well, I don't have any cognitive services yet, so how do I do that? Well, you can simply, using the Visual Studio Tools for AI extension in Visual Studio here, we can right-click, create new cognitive service. You can select your Azure subscription, and then you can select the type of service that you want, and then you can go ahead and deploy it. But as you can see on the left-hand side here, I already have a couple of these cognitive services deployed that I can simply use. And so as you have some other folks in your organization, perhaps other people in your team, creating cognitive services, you want to make sure that I'm just going to go ahead and use the one I have. That's the easiest way to get started. Now, I'm going to show you how we can simply take one of these instances of a cognitive service, like this text analytics one, and right-click and create a new application. Now, I'm going to give this a name that I would never use in production, but just to make sure that it's unique here. And so, okay, great. So it generated the code here. We can see that it's got the references to the SDK automatically, and it even included my subscription key and my service region, which are required to actually call the REST APIs in the cloud. Using this SDK, then, we can walk through and see, okay, well, I've got some sample data, which is great, and we can actually even mouse over this and learn some things about the different classes. And so you can obviously read the online documentation to get started, or you can look at the code, and then you can customize the code because it actually runs. So let's go ahead and set this as my startup project and run this. And we'll see that it's going to identify from this language input, then what was the language that it detected. I'm going to see, okay, well, let's do some key phrase extraction out of those sentences, and then obviously do some sentiment analysis, because that's interesting. I had the best day of my life during this talk, but maybe later today the speaker put me to sleep. No saying anything about anyone else, but this is pretty fun stuff. Okay, so point here is that by taking this cognitive service in the cloud that's already a pre-trained model, you kind of don't have to know anything about machine learning or deep learning, you can generate some code, call it, and then get intelligence in your application super quickly. Now, even more complicated scenarios like vision, writing code to actually parse an image and figure out what's going on with an image is pretty complicated stuff. But with deep learning, training a model to be able to do that is pretty neat stuff. So let me show you how this works. We use the exact same process. I simply right-clicked beforehand to speed things up, generated the code, and now I'm going to pass in an image just to show that this is real stuff. And I'll grab the path. So I went on a trip to Thailand recently, and I've got a picture of me with an elephant here. Now, it's going to pop open the image, and you can see that it's even going to generate a caption, a person petting an elephant. Like, writing the code that can figure out what's going on in this picture, say a person petting an elephant, it's pretty neat stuff. Like, you can't write a rule. You can't write code that's going to properly interpret that without using something like deep learning. And again, we don't write the code to do it. We train a model, and the model interprets the input of the picture and then generates some output. And this one generates a couple different outputs because there's some tags that kind of describes it and then constructs the description of it. So using pre-built AI to speed up the construction of your intelligent application is the easiest way to get started. And using Visual Studio Tools for AI makes that even easier. But let me show you another scenario where if you want to classify some images, like if you want to build a robot, like I'm pretty thirsty, but I haven't had time all day to go and grab a drink. So if I want to create a robot that goes and gets a drink that I don't like sodas, but I do like coffee and beer. So how would the robot know what is soda, what is beer? Well, we need to train a classifier where it can analyze some images, where when it's picking up something, then it says, okay, this is Coca-Cola, this is a latte, et cetera, et cetera. So using custom vision AI is a cognitive service in the cloud that enables you to upload your own images and easily train your own model or customize an existing model. And so we can say add some images, we can upload, and then we can upload a bunch of images of Coke and add that. And once we've uploaded them, then we can go through and retrain the model. And click train. Now, this process is using a pre-built model in the cloud, customized with your own images that you've uploaded. By using a pre-built model in the cloud and then customizing it, you can rapidly speed up your training cycles so you can get to something that's useful a lot faster, and you don't have to have all the understanding of how that deep learning model worked. However, we can also see we still get this measure of precision and recall. You can kind of think of these as your quality metrics. I would never ship code to production that I didn't know how well it was going to work. And so this is working on the notion of a training data set and a test data set, where instead of writing test cases in code, you provide some examples that you also label and say, oh, this is known to be Coke. Here are some examples of Coke images. Now, did the model properly learn from all those examples of Coke that this other particular image of Coke is in fact a Coke? And so then that's kind of the measure of quality, if you will. And then once you have this model, you can either just simply call the REST API. You can click prediction URL here, and then you can see it just generates a REST API for you. And we all know how to include a REST API in our applications. Or, if you prefer, you can also export that model. And exporting that model then enables you to use that model on a device that has no network connectivity, for example. And so that way you can ensure that you have that intelligence with you wherever you go. Now, I don't know about you, but I just did a bunch of clicking on a website, and I'm like, yeah, Visual Studio Dev, I don't really like clicking around every time I want to update my model. We might want to update our model if the quality metrics aren't where we want them to be. So over time, say we want to make sure that we identify a new type of soda or something. Well, we need to upload new images. And so continuously retraining our models is super important to make sure that we get the quality that we want. Now, to do that with Visual Studio Tools for AI, simply right-click on the custom vision project and again, create new application. And then you can see we've got a retraining project this will generate. So you can either choose C# code or Python code, you choose. It'll generate this code for you that enables programmatically retraining. So to speed things up again, I've already done this. But you can take a look at the code, and this is simply going to iterate over the local directories. Let's go ahead and run this. And I'll call this theater. And then I'll specify the input image directory. And so this notion of having a training data set and a test data set as separate, you always want to make sure that your training data set doesn't contain the same image that you use in your test. Otherwise, you're kind of skewing the results. So we want to keep them separate. So we'll specify drinks train. And then, so we'll specify where is my training data set, and then also where is my test data set in the same directory, and then the name of the model that I'm going to download. I'll go ahead and overwrite it. And what this will do is now it'll upload all those training images. It's going to label those training images based on the directory structure, and then it's going to execute a test case in the test directory, and it's going to tell me what the prediction is so I can determine whether the quality looks good or not. So as soon as these images are uploaded, now it starts training. And so this is, again, using the power of Azure, the pre-trained models that are already there greatly accelerate the rate of training. The model's already trained, and I can see that it's correctly interpreting one of the images as a Coke. One of them, it's like 62% sure that it's an espresso, and then my Batman coffee image, it knows for sure is a latte. And this image was pretty darn awesome. There is just no question it was anything else. Oh, sorry, in the test. Point here is that I want that drink. Point here is that we generated an executable with almost no work. I simply right-clicked the Custom Vision Cognitive Service, generated the C# code that iterates over the sample data, uploads the sample data, kicks off training in the cloud, and downloads my model. Now notice this model.zip file. This is a TensorFlow model. I can take that and use that anywhere I want to. We're pretty much the only folks that are going to say, hey, yeah, go and use our cloud to train your model and then take it wherever you want. It's super easy. I mean, it just doesn't get simpler than this. But still, the question is, okay, well, what do I do with this model to include it in my application, right? So I want to move on to actually show you how to include a trained model in your application. Now, we've created some other templates in here called model inferencing library templates. And I'll show you how to use this in a real application in just a second. But I want you to see that we can import either trained TensorFlow models or ONNX models into an application. This is going to parse the structure of the model. It's going to look at the inputs and the outputs. So then it'll generate the method to actually invoke the model, regardless of whether it's TensorFlow or ONNX. And that ensures that you can run your code anywhere on a Windows device or up in Azure or in a Docker container, etc. Now let me show you how this actually works. We'll proceed here. And we'll go ahead and grab my Drinks ONNX model. And this is going to analyze the model structure. And then because we're generating code, now I always have some naming conventions for classes and such that I prefer, but let's call this Drinks class, Drinks. And even though the model itself, notice the model inputs, or it says input 0 and output 0, I wouldn't want that in my code. So I'm going to go ahead and edit this and say, actually, I want to call this, input drink image, and I'm going to output a prediction. If I can type. Okay. And I'll hit OK. And so now this is going to generate the C# code. It's going to place the appropriate runtime, whether it's TensorFlow or ONNX, in my project, so I don't have to go and find the SDK somewhere else and figure out how all that magic works. Now you can see I've got the ONNX model here, and I've got the code right here. So you can see the Microsoft ML scoring reference up here, and then this will initialize the drinks image to list, and it'll return the output names. So I can include this in my application. Now, I can also simply right-click and import more models if I want, because sometimes we need to put together a bunch of different models in a single application to provide an intelligent experience. Now, let me show you what that looks like using the exact same process. So I'm going to just flip over to the PowerPoint real quick to just give you an idea as to where we're going with this. All right. So we customized our model, and now we're going to create a custom model from scratch. So with this, we start with our input data, and we want to iterate over this. So again, VS Code, VS Tools for AI is just a tool. We're going to use Azure Machine Learning and Azure Compute in the cloud to actually train this model. So if you've seen this architecture slide before, that's where we're at. With tools, using services in the cloud on top of compute. Now, what we're doing is we're closing the gap between the data scientists and the developers in a way in Visual Studio, where I'm going to show you both how the data scientist can train a model and how the developer can use that model in their application. And this is usually kind of the hard part for folks, because data scientists use different tools and frameworks than developers normally do. But by using the code generation strategy that I just showed you, we're closing that gap. Now, the app that kind of motivates this, we just launched the AI Lab website. If you haven't seen it, go check it out, play with it, it's fun. This is one of the experiments on that AI Lab website called the Style Transfer Demo. We've all seen things like Prisma or whatnot, an application which takes an input image and converts it to a more fun image. And the way we do that is we use a bunch of sample images, and then we use the power of Azure to process them using a pre-trained model called VGG, which is just a big pre-trained network that kind of understands a lot of things about how to deal with images already. And then we're going to use TensorFlow and Keras to add some custom intelligence on top of that by using an input style image where we want to make it look like a mosaic, or we want to make it look like some other form of art. If you're interested, we've got more details on the website, but fundamentally the key thing here is that we're measuring loss, and we want to reduce the amount of loss. We want to identify the semantic similarity between the input image and the output image, but also make it look as close as possible to the style image at the same time. And that's where the Python code comes in handy here. So let's go ahead and flip back to Visual Studio so I can show you how this actually works. All right, so here we've got our Python project in the lower right-hand corner and the picture style transfer code as well. Now, Notice we've got the Keras TensorFlow code in here. If you don't know how to write Keras TensorFlow code, that's totally fine. We do have integration with the Azure Machine Learning stack in here, so you can actually download a bunch of example projects super easily as well. But because this is a demo and I'm running out of time, I'm going to go with the code that I've got. So we got a training script here. Now I can step through and debug my Python code on my local machine using Python tools for Visual Studio here, or I can right-click and submit my job to the cloud. Now, I would do that because processing these images is very compute intensive. So I can iterate on my code locally, step through and debug it, and then submit my training code to the cloud to use a more powerful GPU VMs or Azure Batch AI, which dynamically can spin up machines that have powerful GPUs and train across multiple machines all at once, which is pretty awesome. So I can simply select my Azure Batch clusters. I can use Azure Machine Learning to keep track of my experiments. But I'm going to go ahead and select a GPU VM here. I'll train the Mosaic style image. And I always maintain my configuration kind of like I do my code. I've got a file here. I'm going to pass in this Mosaic image as the style image and refer to the data set that I've copied to the machine. Now I can go ahead and submit this job and then also keep track of all of my jobs. So now I can see that the job is running on the GPU VM. And just to speed things up a little bit, previously I had already run one using the Scream portrait as the style image. I can right-click here. I can see the TensorBoard results as it's running. So we've integrated TensorBoard both for local runs as well as remote runs. This will launch and I can see the quality improving over time, provided that I still have connectivity here. Okay, great, I do, and then I can also access the working folder of each run. So this copies the code, it copies your scripts over to your remote compute so that as you iterate over your experiments, you can keep track of which version of your code you were using. And then I can access the model file as well. Starting to run a little bit slow, so I'm going to go ahead and show you how the app works. Here. So we can see in the output folder, we'll see the TensorFlow models. Now, in the app I'm going to show you, I've got a models folder, and I generated code for each one of these models, the candy style, the feather style, et cetera, et cetera. And so this is simply training one model per style and including each one of those in the app. And now I'll show you the app here. And you can see with this drop-down list, I'm simply selecting each one of these and executing the code that I had generated from each one of those trained models based on the input parameter of which model do I want to use. And notice I'm using the Surface Book with the local GPU, so the inferencing is pretty decent speed for a laptop. If you use a more powerful GPU, of course the inferencing is going to be faster. But by simply importing these models into your application and generating the C# code with the Microsoft ML scoring library that runs both ONNX and TensorFlow models, it's really easy now to build an application. It's easy to coordinate with your data scientists because they can have all their Python code in the same Git repo. They can check in their models, they can check in their code, and you can collaborate together using Visual Studio and Visual Team Services. And you can track your models just like you would any other asset in your project. So thank you all for coming. Really, really appreciate your time. Now, like I said, I put in a bunch of screenshots in here so that you can follow along at home. And so we'll go ahead and skip to the end. Now remember, the easiest way to get started, just use pre-built AI. You don't have to know how to train models. You don't have to know any of it. It's super easy. You can use custom AI in Visual Studio Tools for AI or Visual Studio Code. and I've provided some links so that you can learn more after the fact. So, thank you.